Summer is a time that people really look forward to, especially us Filipinos. We love having outings, hanging out, and going to beautiful beaches. But summer here in the Philippines is very hot, and ice-cold beverages are always needed for heat and thirst to be quenched. Yet sometimes, lack of ice is experienced, for ice could not retain its form whenever the temperature is high and refrigerators are not available. And it could be very troublesome to walk long distances just to buy ice, and it could also be very costly. These are the reasons why we came up with the idea of having a portable solar-powered cooler with water heater. Not only is it environment friendly, it is also very handy, for it could cool beverages without the use of ice on hot days, and it could also boil water separately on cold days. Basically, this project is more on the refrigeration process, except only for the source. We used a solar panel in order to provide electrical supply into its battery. We will talk more on that later. These are the materials used in this project. It contains basic materials such as commercial cooler, solar panel, charge controller, battery, inverter, compressor, used aircon condenser, copper tubes, and some scrap wood. With teamwork and engineering knowledge, we fused them together and ensured that we met our objectives. The heat of the sun supplies the heat energy absorbed by the solar panel. This heat energy is then stored into the battery, taken as a DC electrical charge. The electrical charge in the battery is absorbed through the charge controller. This controller is installed to act as the power indicator. The battery then supplies power to the compressor, which powers up the whole refrigeration system. But before the charge reaches the compressor, it must first go through the inverter, which translates the battery's charge from direct current to alternating current, which is required to operate the compressor. As the compressor powers up, it then pumps the ammonia, a chemical which is used as the main refrigerant. This refrigerant is needed to effectively remove heat inside the cooler. This refrigerant is pumped along copper tubes that were previously coiled along the walls of the inside of the cooler. These coiled copper tubes act as the evaporator component of the refrigeration system, which reduces the temperature inside the cooler. The refrigerant then is pumped to the condenser, which is the next component of the system. The condenser, as the name suggests, condenses the refrigerant back to liquid form. The refrigerant completes the cycle by being fed back to the compressor, and the whole process repeats, thus maintaining low temperature within the cooler for a longer period of time. So, why use an ordinary cooler if a special type of cooler like this is available?